So hey guys, welcome to our video. So today is a CodeChef contest. So we are going to give this, and maybe we will be solving a lot of questions today. Maybe, I don't know. And for those who are watching the video first time, I would like to tell you that I will be solving every problem very quickly today in the contest, but later on I will come back and explain you the solution for each problem, or in the middle only when I will be like done with the problems. So just skip to the last part if you want to understand any particular problem, or you can just watch when I'm attempting the problem and then watch the explanation which I am giving afterwards, because while attempting the contest it will not be very good for me to explain the problem. Chef is participating in an election going up against his enemy anti-chef. There are n voter and their votes are described by binary string s, where s if the voter vote for chef, the voter will be counted one by one in order from n. Chef can say that to stop the count, and the remaining votes will not be counted. Chef wants to win. How many way are there for chef to win depending on when he said to stop the count? Two way are said to win. Ah, quite easy problem. Actually, what we can expect from CodeChef, we just have to we just have to what we have to I don't know. We just have to go in the sequence, and int v1 should be the votes for the chef, and v2 should be the votes for the opponent. So for int I equals to 0 to n, we will just import a character. If okay, c is equals to 1. If this is the case, which one is okay, the chef is going to get this vote, else the opponent is going to get the vote. And after each of this, we will check if v1 is greater than v2, answer plus plus. I don't know whether we have to check for equality or not, but we will get to know when we will run the solution. 302, till now it is correct. Let's submit this. You had an array of size n and a cost array c of size n. You will do exactly an operation of following types. Okay, correct. Following type, choose I such that I is okay, and then denote AI from okay, delete AI from the array, okay, and associate cost of this operation is AI into CI, okay. After each operation, the remaining part of A are concatenated and reindexed for 1 to okay mod A, or the length of A. Note that the array C is not modified. Find the minimum total cost needed to perform the n operation, thus deleting A. I think we have to just find the minimum C and use it. Okay, we will move from 1 to n. We will take the record of the minimum C and just multiply it with the with A. Oh, not this. Okay, the thing here is that this concept. I don't know why I have not copied paste my template here, but it doesn't make any sense. It doesn't make any difference. Sorry. So we will just input A and C, and I have already told you the solution. I think so. It might be correct. So because it is greedily possible to do so, we can just like delete the initial elements first and move the AI in in the right direction, and by this we can assign the minimum C which is coming before uh, the current index. So answer would be a long answer. Sometimes it becomes very tough. It should be min. Minimum total cost, yes. 1E18. Oh, it will go through an error. Yeah, I knew that. I just knew you were the someone waiting for me. Yeah. For an array A of size n, define FA as okay. For for every index from 1 to n minus 1, it will be it will be zor of AI and AI plus 1. This denotes zor na. Yeah. Yes. Here okay, zor in this is defined as 0. If is defined as 0 for n equals to 1. Okay, got it. Even integer n and m, consider the array A satisfy and is between okay. Let S denote the maximum possible value of FA. Find the number of arrays A satisfying the constraint such that FA equals to S. You have to make the sum S, and sum is the zor of the consecutive elements. I don't like this type of question much. Combinatrix. Okay. Here they are saying that as denotes the maximum possible value of fa, and then they are saying that find the number of arrays a satisfying the constraint such that fa equals to s. I'm not getting, like, we have to, like, we can consider fa which are less than s or not. Okay, s is not given. So what are they asking? I'm not getting to. Consider let s denote the maximum possible value of fa. Find the number of arrays a satisfy. Okay, got it. The maximum value which we can get by this is s, and we have to find how many arrays will be there which has the this equals to s. So we have to do that. Okay, I got it. So the maximum value which we can get from this is I think n, maximum value max will be equals to n into m, because you can take, no, we can take this. n minus 1 m. I think this should be the maximum value which we can get. And what we can do, if we have maximum this, then we have to make consecutive A's to such to be such that their XOR will be equals to m, like after taking the XOR, like the bits in one number should not be in another one, but they can have common bits. Okay, if you set any bit other than m in any one of them, okay, this is very 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 okay. We can take 0 to 6, that's why here it is 7. All will output 0 only. Then here we have we can just type like this. Okay, now we have to just find out, like what will be the arrays, or like we have to just find out what will be the value of the consecutive elements such that they will produce m as their XOR. So what can be values such that we will produce m as XOR? Can we loop from 0 to m and find um, n equals to 1, say out. If we have 2 and 3, we can take values from 0 to 3, and the maximum will be 3, which I said already. So using 0 to 3, we can have 0 3 0 3 0 3 0 and 1 2 1 and 2 1 2. These are the values which we can have. How many such number will exist such that I think I should attempt this question later on. Let's move to C. Sorry. Sorry, D. Called as conjecture, if I'm correct. You can do the following operation. If n is even, choose to change n to either n XOR 3 plus 1 or n by 2. If n is odd, n to n XOR 3 plus 1. Here XOR check if it's possible to go from n to 1. Print yes if it is possible and no otherwise. Okay, if we check what is happening in this operation, if you take the XOR of even number with 3, it will just flip the second last bit, and if you add 1, it will again flip the bit and add the 1 to whole of it. So this is particularly what it is doing. If the bit will be already set, it will not change anything. If you do this and the second last bit is not set, then this operation will not make any change. As when you no, this will make change. If that is set, then this will not make any change. And when this is that is not set, this will make change. And this operation will result in just unsetting the second last bit or setting the second last bit in any odd integer. Nothing more will change in this by this OR. What I can see here is that if I have any even number, it will remain even by this operation, but it will change if I apply this operation. But if I have any number, what it will do, it will just flip the second last bit and keep other bits same. So what I can observe that if we have set bit at second last bit, we can just use this to unset that. And if we have, and we can just shift the number. Okay, n by 2 does shift the number. And if we do n by 2 to any number, it will like, okay, even number. If we do this to even number, this you can only do this to even number. Okay. If the number will be odd, it will not be possible to make it, what we say, this. Because if you take like the options, if the number is 3, they are saying it is possible. But okay, if it is 3, then it will be possible. But other than 3, I don't think it will be possible. For 7 and 9, it will be no. Okay. And for 10 also, they are saying it will be no. But how they are saying that? I'm not able to understand what this operation is doing. One thing is clear: if there is any odd number other than 3, it is not possible to make it, what we will say, 1. uh, and if it is 1, then it is already 1. So no change is required. But if it is even, what we can see here, if it is 10, it is outputting no. For other 8, 6 and 4, it was outputting yes. So why isn't it doing for 10? 10, what will be the case? In 10, we have 1 0 1 0, which represent 10. Okay. This is even, and if I perform this operation to it, it will become 0 1, and if you add this, okay, if I have said that if the second last bit it is same, this operation will not make any change. So for any number where the last bit is not set and second last bit is set, we will not be able to make it. So if we take the case of 2, okay, we can just divide 2 by 2. But for 10, if we just divide it by 10, it will get, okay, only for 2 it will be possible. Other than that, if the second most significant bit is set, it is not possible to make it. Or if, or just it was pretty observation based question. You have to write it on pen and paper a little bit. I have also done that, because imagining bits is not an easy job. So if it is n equals n is greater than 3, for 1 2 3 it is possible to, like, so like n is less than equals to 3, it we will just output say out yes. For others, we will check if, let's try see out. N modulo 2 or n you can just check it with 2. I hope this will be correct. This will run correct for this test case, that I am sure. No, no, why is it outputting no? Okay, 6 is also like that. So, what's the problem with 6? 6 is a multiple of 3 in 2 to the power. Okay, what other is outputting? I think I'm just overfitting the solution. If we can reach to 3 by any of this, it will be possible. It can feel like that I'm just fixing my code for a particular edge case, but I think like this will cover a lot of test cases, which it is not covering right now. I don't know why, but it will. Still not correct for 6. Okay, it is not entering. Oh, I have written here. Maybe it will can give me a wrong solution. Correct. Yeah, I knew that. If the hard version will be same, then I have to just copy paste it. We have to find the minimum operation. It's not that easy at all. Mm, but we have solved that, then we can solve this too. But I would like to just copy this and paste it here. Mm. If this will be the case, then we have to just like do this operation, and at last we have to do this operation, and it will be like done. And for others, if it is odd, it will not be possible. So that will ease our. And for others too, for others, what we can do. Okay, what we can do for others, like mm, okay, we were just checking that if the number is even, the second last bit should not be set. But okay, if it will be set, then it is will not be possible. But if it will not be set, then how it is going to help us? The main question is that. The main work is from this, I think. Constraints are still same. Mm, what does it do? What does it do? If we have, if the number is even, the two conditions, two cases are there that second last bit will be 1 or 0. If it will be 1, then it will make the second last bit, the XOR operation will make the second last bit 0 and the last bit 1. And if you add 1, then it will again will be 1. So it will not make any change if the second last bit will be 1 and the last bit will be 0. But if the last and second last bit both are 0 0, then if you take the XOR with 3, it will become 1 1 and it will just add 1 and just move 1 to the whole number, or it will just add, what it will add, it was 0 0, then it will be like adding 4 to the number. So these two things are only there. So this will break down into a single, what do we say, single operation. It can be like you can just add 4 by this. We are adding 4 by this, and we are dividing by n by 2 by this operation. And this operation, what will this operation do? This is just flipping the second last bit. So we have 3 operations: flipping the second last bit, which will be always be done if the number is odd, so it is one operation. And if the number is even, if the second last bit it is set, then only one operation is there, dividing by 2. And if the second last bit is not set, then we can add 4 or divide it by 2. So these two operations are there for us. So what we can do by these operations? If we add 4, it will remain a even number only, and if you divide it by 2, you are just adding 2. Okay, and dividing it by 2 may change the number. Okay, and okay, in any point of time, if the number becomes an odd number other than 3, then it will not be possible. So we will just kill those nodes. But still there will be two options for us: dividing it by 2 or adding 4. we can think it in reverse order as well. Like this operation will be only applied if the number is odd in the reverse case also, and this operation will be applied if the number will be odd or even. It doesn't matter. I'm not getting it actually. Sorry. 4 minus 1. Yeah, that's correct, but now we have to output how many operation it will take. You have to output just the number of operations. We don't have to output the operations which we perform. We have to just output the number of operation which it will take to do this. So if it is already 1, it will be 1. If it is 2, it will be 1. Oh, okay, 0 is 2 is 1. 3 is also 1. And 4 is to 2. For this type of number, it will be just int equals to Zero one one. Okay. If both of the bits are not set, then what this operation was doing? Okay. Adding 4 to it, which will not change in much things. If if any if somehow we encountered any what we say, any odd number in between, it will be impossible to make it true. So keeping this thing in the mind, we just have to avoid the operation which will make the number odd. Okay, so if this is the case, then we cannot move just apply the divided by 2 operation like many times. So what we have to do, we can add 4 to even number, but there will be a lot of even numbers, as odd number will not be there much, because as soon as any odd number came other than 3, it will not be possible. So all we will have will be even numbers, and we can move even numbers to right side, but what it will do, it will not help us much. As bit will should be in the pair. If they will not be in pair, it will be tough for us. No, no, no. If it will be in pair also, then it will not also be possible. So if the number is even and second last bit it's set, it will be negative. But we if we start with 0 0 at the last, it will be possible. But how is it happening? I think we are just adding 4 to the number until it becomes 2 to the power something, and we are just then dividing it by 2 and just outputting the output. I think that's the only way for this. What if okay, first we should work on this solution. um, it is correct, outputting correct, but I think there is some problem. There will be some problem as like this will be even, but the difference of both of them will not be always be divisible by 4. So what we have to do is that we have to make it divisible by 4, or we can just okay, now it is outputting 1. Oh, okay. 0 1 1 2. I think that this might work. I'm just which will be the better solution? Which other can be a better solution? Uh, we can make it in the place of 1, we can use 3 also. Oh, Okay, this is also not an like tough question, I would say. Like we are just have to take two integer a and b, which will be starting from 0. This is also 0, and sorry, we will just like according to my solution, n will be of no use, I think. Like we have to maximize it, and if we choose any integer, like if we have a, okay, let a xor b will be equals to m. But if you choose any other integer other than a at the third place, it it will not give us m. So we need, and why is having XOR of any number with m? Okay, we can have any number less than m. So we can have, maximum will not be n into m, n minus 1 into m. The maximum will be something different. It will be the number which will be having all set bit after the second set bit of m. No. We can have all set number after the first significant first set bit of m, and we can move these bits in the number, and it will give us the perfect output. Okay, so we just need to find the last set bit of m, and we can just like divide the bits between two numbers, but it should be such that there should not be there should be a range, there will be a range where like you will have one first set bit of m, then another set bit, the most significant one of m, and in this, between these, where the most significant bit lies should not lie the other bits which are in between. If this will be the case, it will make the number greater than m, which should not be. So Like A will have the most significant bit of M, B will have the second most significant bit of M, and we can just play with the bits after B. I hope this should work. Like, am I breaking somewhere? Oh. Hmm. If the bit is set, you can put it in any number, but in any one number. Okay, okay. And bit is not set, then also you can put it in any number. Yeah, because we are going to set every bit after B, of course. So why isn't it outputting correct output? So I think I should leave this contest here only. I'm not able to solve much question today. Uh, I'm able to solve A, B. Okay, my graph is the downfall. I am able to solve A, B, and D today. But it was a nice contest. Bye bye.